Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper from the Hugging Face trending list, published on October 1st, 2025, about 2 days ago. The Big Hook is a compact 250 million parameter vision language encoder that outperforms models up to 10 times larger on document retrieval. The paper is titled ModernVBERT Toward Smaller Visual Document Retrievers, and as we will see later, the implications for efficient training and deployment are significant. Beyond the headline, this paper traces gains to bidirectional attention with masked language alignment, higher image resolution schedules, late interaction contrastive matching, and mixed contrastive data that even includes text-only pairs. On Hugging Face, you'll find ModernVBERT weights, including 291 million and 252 million parameter checkpoints, plus ColModernVBERT. Pages include transformers and ColPali snippets, retrieval and embedding examples, flash attention tips. Figure 1 shows the performance versus size trade-off, meaning how much retrieval quality you get per model parameter. The chart places kernel ModernVBERT high on the curve, so it delivers strong VLM scores despite a compact footprint. Multi-vector or late interaction means the retriever matches queries to many token vectors instead of one pooled vector, which helps with fine document details. Compared with much larger decoders, the compact encoders cluster closer to the Pareto frontier here. So, while Figure 1 gave us the trade-off picture, Figure 2 shows a masked language modeling-based early fusion architecture for document retrieval. Early fusion means visual patches are projected into the language model token space, so text and image tokens interact directly. The pipeline uses a vision tower, pixel shuffling which compresses spatial detail without losing context, and a linear projection before a bidirectional encoder. Masked language modeling teaches token-level alignment, so late interaction retrieval benefits, because the model learns which image regions explain each word. Table 1 shows that raising image resolution boosts document retrieval quality. The table compares inputs from 512 to 2048 pixels, and the highest score appears with a high-resolution cooldown, which means a short final phase trained on large images. Document retrieval improves because small text and layout cues become readable. Non-document tasks do not consistently benefit, so averages stay roughly flat. The practical takeaway is to prioritize higher resolution schedules for documents. So Table 3 ranks visual document retrievers on the VLM benchmark, which is a suite of document retrieval tests, and compares accuracy to latency on CPU. The lower block shows sub-1 billion parameter models, where kernel ModernVBERT posts the highest average score at about 69. The upper block lists larger models, which achieve similar accuracy but often cannot run on standard CPUs. The table also reports per query latency, so the compact 0.25 billion model stays responsive. Alright, 2 takeaways stand out. Bidirectional masked language alignment plus late interaction matching delivers strong token-level grounding, and high-resolution training schedules unlock big gains on document images. The broader implication is clear. Compact encoders can replace huge decoders for retrieval, cutting cost and latency while staying accurate. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.